Hello everyone, we're going to just kind of take everything we've done in 2-3 and kind of put it all together, do a little bit of practice here. So the first thing I'm going to do the same problem two ways. I'll do it with long division and synthetic division, and we'll kind of compare and see how they're related. The first thing, if you're going to do long division, is you need to have the dividend 2x cubed underneath your little division symbol. But remember, if you don't have a term there for like x squared, put a 0 in there. That's going to help things line up. So 2x cubed, 0x squared, plus 1x minus 4. There's my dividend. And for my divisor, I have x minus 3. So x minus 3 is out here. Now, long division, you're trying to figure out what you multiply x by to get 2x cubed. So x times 2x squared will give you 2x cubed. And now we distribute 2x cubed into the divisor. I'm sorry, 2x squared. 2x squared times x is 2x cubed. And 2x squared times negative 3 is negative 6x squared. Since we're subtracting, this is where you flip the signs. I like to use a different color so I can tell that I did it, and then those go away. And every time you do this, that leading term is supposed to cancel. Now we just do the same thing over and over again. 0x squared plus 6x squared is 6x squared, and I'll break down my x, and now I just do it again. So x times what gives you 6x squared? 6x. Distribute to 6x. 6x squared minus 18x. And again, you flip the signs. Minus, plus, those should cancel. Looks like we're getting close. Let's see. 1x plus 18x is 19x minus 4. And now I do this one more time. So x times what gives you 19x? 19. Distribute to 19. 19x minus 57. 19 times 3 is 57. Now we'll make that minus plus, and those cancel. So my remainder is negative 53, positive 57 minus 4. Oh no, is positive 53. Positive 57 minus 4 is 53. So my remainder is 53. Great. Now, normally we're going to write that out as quotient times divisor and expand it, but I'm going to do it synthetically, and I'll see if I get the same answer. And if I do, then I feel pretty good about it. So I'll do the synthetic division now with the same thing. So for synthetic division, you put the coefficients of the dividend up here, 2, 0, 1, negative 4. And with synthetic division, if you don't put this 0 here, it will be wrong. Long division, you can sometimes just like move stuff over and make it line up, even if it doesn't look great. But synthetic division only works if you actually put that 0 in there. So my coefficients are 2, 0, 1, and negative 4. There we go. And now, if you think about it as like I'm giving you a factor, I want you to test a 0. I want you to plug in positive 3. If x minus 3 was a factor, then 3 would be the 0. This is the way I'm going to have you guys think about these. Now we're going to drop the 2 and let the games begin. 3 times 2 is 6, and now we add. 6 plus 0 is 6. 3 times 6 is 18. 1 plus 18 is 19. 3 times 19 is 57, and 57 minus 4 is still 53. Now, if you look, you might have seen a lot of those same numbers that I was talking about before. A lot of the same multiplications happened. If I did 2 times 6, and I was like, where did I do 2 times 6? Didn't I do that somewhere else? I think I did. Or maybe it was like 3 times 6 is probably what I should be looking at. Oh, yeah, there's your 18 right there. And there was my 3 times 2. There's your 6. Like, oh, okay. All these numbers are popping up. But what you really care about are these coefficients. 2, 6, 19, and then your remainder is 53. So when you do synthetic division, you took something that was degree 3 and you divided out a factor. So now these are coefficients for a degree 2 polynomial. 2x squared plus 6x plus 19. That would be your quotient. If I said write it as qd plus r, your divisor is x minus 3, and then you throw plus 53 in there. Doesn't matter which way you do it in this problem, that's your answer. If I say quotient times divisor plus remainder, that's your answer. Let's try another one. Okay, create a polynomial. So this is kind of like the activity, the exploration we did. First, let's start with the zeros. If negative 1 is a 0, then x plus 1 is a factor. If 2 is a 0, x minus 2 is a factor. And if 4 is a 0, x minus 4 is a factor. Now, are there any bounces? If you look at this at negative 1, it bounces, so that needs to be even. And it looks like it opens down, but I'm going to come back to that when I deal with the this guy. I could put a minus sign out front, but I'm going to start expanding. So this is going to take a little bit. X plus 1, x plus 1, x minus 2, x minus 4. So I have to expand all this out. That's going to be x squared. 1x and 1x make 2x, and 1 times 1 is 1. So there's the first part. Now I will distribute the x minus 2 in. X cubed minus 2x squared plus 2x squared minus 4x plus x minus 2. I'll combine like terms. Something will probably go away. That goes away. X cubed, that's minus 3x. And then x minus 4. One more time. So x cubed times x is x to the 4th minus 4x cubed minus 3x squared plus 12x minus 2x plus 8. Combine like terms. 12 and negative 2 make positive 10x plus 8. So what I'm going to do is graph what I have right now and just see how I did. Because if I did that wrong, then everything else is going to be kind of a waste of time. So let's see if I have that part correct. X to the 4th minus 4x cubed minus 3x squared. I guess plus 10x plus 8, I believe. Plus 10x plus 8. All right, so we look at that. And now all I know so far is that I should have my x-intercepts at -1, +2, and +4, which, -1, +2, I do have that. Now, there's two other things that I want to look at to create this graph or close to this graph. And the one thing is I want it to be opening down. So I know I need to put a minus sign. I know I have to distribute a negative. But I also want the y-intercept to be -4. And right now the y-intercept is 8. So I'm actually going to distribute a -1/2. And if I do that, I will get -1/2 x to the 4th. Negative times a negative is positive 2x cubed. Negative times a negative is positive. This will be 3/2 x squared. And then -1/2 times 10 is -5. And -1/2 times 8 is -4. So once I do that, I should see almost perfect. It's going to be a little bit off because I don't think I cubed something, but it's going to be really close. Now, I could just take it and put the -1/2 out front and see if that does what I want. And if you look, like, oh, look, it bounces off of -1. Maybe I'll just screenshot it so we can put them right next to each other. And this guy too. So if I take this and I look, how close are they? Pretty good, right? I have the x-intercept here at -1 looks good. X-intercept at 2 looks good. X-intercept at 4 looks good. The only thing that's not exactly right is right here. And that's a different x-axis behavior. I think I would need to make that x minus 2 cubed to get that little flat spot. But I'm not too terribly concerned about that. If you can get to here, you're in good shape. But again, you should distribute to get it into standard form. This would be your final answer in yellow here. All right, let's see what else we got. Completely factor using the given information. So if they tell me that x minus 3 is a factor, then I should be able to do synthetic division with +3, and I should get 0. Because if it's a factor, if x minus 3 is a factor, 3 is a 0. 6, -23, -6, 63. So let's see. 6, 18, -5, -15, -21, -63. Great, I get 0. So now I have 6x squared minus 5x minus 21. That's my quotient, and my divisor is x minus 3. Now this problem says completely factor. Well, look, we just factored out the x minus 3. And this is a problem that we've never been able to factor before. So that's cool, but now I have a quadratic. And what we're going to start to realize is that once you get to a quadratic, you can always keep going. So we're going to be able to either use factoring or solve using the quadratic formula, but we can always keep going with a quadratic. So what I need to do now is split the middle. So I need to look at my quadratic and see if I can find numbers that multiply to 6 times 21 is 126. So what multiplies to -126? 1 and 126. 2 and 63. Does 3 go into there? 3 does go into there 42 times. 4, does 4 go into 126? 126, I don't think so. No, 124 would be my closest. Yeah. So 4 doesn't, 5 doesn't. Does 6 go into 126? 126 divided by 6. Yeah, 6 and 21. How about, let's see, 126 divided by 7. 7 and 18. Got a lot of factors. I'm just using my calculator, just making a table. 9 and 14. 10 doesn't, 11 doesn't, 12 doesn't, 13 doesn't, and that's it. So 14 now I've got my repeat. So it's all those. It's one of those pairs that I need to add to -5, and I think it's going to be right there. So 6x squared plus 9x minus 14x minus 20. Now that I split the middle, those add to -5. I do grouping now. 3x, 2x plus 3. The GCF there is 7. So now completely factored, I have 3x minus 7, 2x plus 3, and then my other factor that I started with was x minus 3. So that is completely factored. That's something that we've never been able to factor until now, but now that we have synthetic division, we can use that to bump something down into a quadratic, which we can always address. So kind of cool. New skills. Sketch the polynomial. So let's first do this one that is already factored. That's nice. The first thing you have to do is decide what the degree is. And in factored form, you have to add the exponents of all the x's. This doesn't have any x's, so I don't care about that. But 2 plus 1 plus 1 is 4. So this is degree 4. And it's got a negative in the front, so it's negative even. It's going to make an m. Our x-intercepts should be at -4. 1, 2, 3, 4. -2, -2, and that would be -3/2, so -1.5. Wow, that's going to be really close. I'm going to stretch this out. At least give me a chance. 1, 2, 3, and I'll just come out here for my -4. So -4, -2, -1.5. It's still not great. It's going to make an m, so I know it ends like this. And now we just have to decide what does it bounce off of and what does it pass through. So the first thing, when I get to -4, I look at the multiplicity here, and I say, oh, it's even. This factor has an exponent to the second power. When it's even, then it bounces off the x-axis. So it's going to turn around and bounce off. Now we have to decide again for these two. And both of these have exponents of +1, which is odd. So both of these are going to be pass-throughs. There you go. So you bounce off of -4 because it has an even degree multiplicity, and you pass through -2 and -1/2 because they have odd degree multiplicities. Now this says find the y-intercept, but unless we're going to use a calculator, we're not going to do the y-intercept. So here's my zeros, and I have my end behavior. I'm going to write in limit notation. So I know I need two of them. It's the limit of p of x equals, and the limit of p of x equals. So we need two of them, one for the left endpoint, x goes to -infinity, and one for the right endpoint. And I know I'm going to need to do this again in the next problem, so I'm just going to copy that. As you go left, x goes to -infinity. As you go left, it goes down, so this is -infinity. And as you go right, it also goes down, so this is also -infinity. Since both ends go down, the limits are both -infinity. One more, I might have to factor this one first. So let's see, I'll do GCF, x squared plus 2x minus 8. That's easy to factor. That what multiplies to -8 and adds to 2. X plus 4, x minus 2. My pen's not really working right now. So my zeros are at 0, -4, and at +2. Now, this is the one that gets you. Anytime you have a GCF of x, if there's an x in all of the terms, then you have to remember that you could just make x 0. 0 is one of your zeros if you factor out a GCF that has an x. So on my graph now, I'm going to put my zeros at -4, 0, and +2. So that's what I got. And this one is positive and odd, so it's going to look like this. And if you'll notice, all of the exponents are odd, 1, 1, 1, which means they're all pass-throughs. So when I draw this, it should be nice and easy because I'm going to go up, I'm going to turn around, I'm going to turn around, and I get something like that. Well, I missed that part of it, but that's okay. Okay. And that's it. Okay, I can tell that it goes through 0, 0 because it has an x-intercept at 0, so it has to have a y-intercept at 0. And that's really all I can do. I've got my x-intercepts, and I've got my end behavior. So for my limit notation, as it goes to the left, so that's saying as it goes left, it goes down. So as it goes left, it goes down. That means this will be negative infinity because it's going down. And as it goes right, it goes up. So this will be positive infinity. That's it for our sort of mid-unit review. If you can do that, you're in good shape so far. So maybe just hit that like and subscribe button.